Hi friends, my name is Atul and I welcome you into the class of fluid mechanics. Today's topic of the discussion is external function and velocity potential function. So these are the important topics. Based on this, there is a flow of fluid. So we will see some important things here. The phi denotes the potential function, or you can say the potential function is denoted by the term phi. This is a Greek word, okay? And it is a function of space and time. Now, you know, u is nothing but velocity of the x direction, okay? Now, here we represent the potential function, velocity potential function in like this. U is given by minus d phi by dx. V is given by minus d phi by dy. And W is minus d phi by dz. Okay? Now, this was on the Cartesian coordinate. In cylindrical coordinate, it will become UR U theta, correct? So, generally we use Cartesian system only. The cylindrical systems are rarely in use. Now, coming to continuity equation. You know continuity equation is given by du by dx plus du by dy plus dw by dz. Now put the value of uvw in terms of phi. Okay, so it will become, when you put all the things, you will get this equation number 2. You will get this equation number 2. Now what is this equation number 2? This equation number 2 is nothing but Laplace equation. Now this is in 3D. Now when we talk about two-dimensional case, your z component will become 0. So this is the two-dimensional case. Okay. Now, talking about the rotational component, means because of which there is rotation of the liquid. Okay, so when I talk about z direction, rotation in z direction, it is half of, we will take x and y. When we talk about z direction, we will take x and y component and opposite. Okay, so it will be nothing but dv by dx plus du by dy. Or you can say like this, if you remember cross product, dot product, how you will do I, J, K, correct? U, V, W, dy, dx, dy, and dy, dz. So when you talk about I, you will take du by dz plus dw by dy. See here, I means we are talking about x component and put half. Similarly for other directions also. Okay, so you are doing taking cross product only, nothing else. Now some important conclusions from here. What are those important conclusions? If your this function, velocity function, potential function, it satisfies Laplace equation, then there is flow of fluid. There is flow of fluid, or you can say for flowing of a fluid, the necessary condition is the velocity potential function should satisfy the Laplace equation. Correct? Next, just now you have seen this. Now put the value of u, v and w. Put the value of u, v and w in terms of potential function. Okay, put here you, what you will get. See, you are getting this and this. Okay, when you will solve, it will become 0. This will also become 0, and this will also become 0. Okay, so what we are getting, all the rotational component are 0. all the rotational component are 0. Means it is irrotational flow. It is irrotational flow. So there are some properties of a potential function. What are those properties? The velocity of potential will exist. The flow will be irrotational. When the flow is irrotational, then only the velocity potential function will exist. Next, if velocity potential function satisfy Laplace equation, it represents possible flow of the fluid. Fluid will flow when it will satisfy the Laplace equation. These are the two outcomes. Now, next, what is stream function? Now, stream function is denoted by psi. Psi. Okay. Now, what is the difference here? See, in previous case, u was minus d phi by dx, and v was minus d phi by dy. But here components are interchanged. In v it is d psi by dx. In u it is d psi by dy, but minus. In first it is not minus, another it is minus phi, because we are rotating the things by 90 degree. We are rotating the components by 90 degree. Now writing continuity equation du by dx plus dv by dy equals to 0. Put the value of u and y in terms of stream function. You will get continuity equation equals to 0. So this is the case for possible fluid flow. In first case it should satisfy Laplace equation, and here it should satisfy the continuity equation. Clear? Now what about rotational component? Here it will be minus. Here it will be minus. In previous case it was plus. Now here it will be minus. Now put the value of u and y. Put the value of u and v. Okay, put the values. After solving you will get this thing. So the outcomes are, what are the outcomes? If stream function exists, means psi exists, it is a possible case of fluid which may be rotational or irrotational. In first case, the it should be irrotational always, but in this case, it can be rotational as well as irrotational. Both things are right. Correct? Now, second thing, it should satisfy the Laplace equation. Then only it is a possible case of irrotational flow. If it satisfies the Laplace equation, it is the case of irrotational flow. These are the important outcomes. The thing is, you should know relationship between u, v, psi and phi. Okay, these things you should know. See here, same thing is told here. Relationship between different things. Now after writing relationship for u in terms of phi and psi, and for v in terms of phi and psi, what we observed this thing. We observed this thing. Now here there is one printing mistake. What is the printing mistake? Here there will be minus sign. So these are the two important conclusions when you are equating stream function and velocity potential function. Thank you for today's session. I hope it was clear to everyone.